Hi, welcome to the second video of the new Electromagnetism version 5 worldwide release. This video is mostly the definitions that you will need to understand the videos as time goes on. Included in this video is going to be the upcoming release schedule, so you'll know when things are going to be released. Also, an introduction to the rules of acquisition, which was missed from last time. And the definitions include the definition of natural versus legacy units, the definition of effort and VIM. This 5.0 means these are new for the 5.0 paper release. These were updated when the 5.0 paper came out, and some of the newer videos in the releases do not have these newer definitions, but we'll discuss all of that. The difference between volts and VIMage. This we're not going to have time for. So the video series coming up these are the original released versions. These came out before the 5.0 paper came out. And there were certain things that needed to be updated in these. That's why I'm re-releasing these as version B. This video's out. This might have some old nomenclature, but the video's still good. And this would be the next video, but it's available now. Next week, we're going to release a magnetic force intro, interfragmentary. I'm not going to read these all down for you. Okay, the version 5.1 paper is dependent on finishing these guys up. I have an experiment I still have to run. This gives me a month of releases to get this other experiment done and the 5.0 paper released. These red ones have already been released to Patreon members. This dates over here is when they're going to be premiered for the rest of the world on the YouTube channel. The dates of these are TBD. Now, if I get behind and I need to get some other premieres to fill up the Thursdays at 9 p.m. slot, then we'll release some more of the experimental series that haven't already been released to the public. These will probably be these guys first. So last time we wanted to talk a little bit about the rules of acquisition, and we didn't have the time for it. So let's talk about the Stinty's rules of scientific acquisition, or just the rules of acquisition for short. Now, what I've determined over my life is that humans absolutely suck at science, and I'm going to show you some examples that'll make your eyes water and your hair stand up on the back of your neck. And this is part of the problem of the very poor deficiency in all levels of training, deficiency in science and reasoning and logic. And we have some contamination in science from mathematics. We'll explain that more when we get to the rules of acquisition series. But in any event, it's part of the reason it took me 30 years is I had to undo some of the bad things that I thought were true that had been trained to me over the years. And I had to get past all of that. So that was a good portion of why it took me so long, is to undo the brain damage of a college education. Okay, now let me give you an example. Let's go back to the year 1900. And what was the population of the Earth? The population was about 1.6 billion people. 1.6 billion people. And what did the leading experts say about heavier than air flight? Well, let's go to Lord Kelvin. Lord Kelvin said heavier than air flight flying machines are impossible. Impossible. These are the same guys that are telling you can't travel faster than the speed of light. Remember that. This guy was the rock star of physics of his day. And I believe this statement was made in 1895. Okay, the New York Times published in October 9, 1903 that it'll take 10 million years for humanity to develop an operable flying machine. Okay, it was written in response to Samuel Langley's failed airplane experiments. Okay, but what happened 69 days later? Well, humanity figured out how to make an operable flying machine. One of the other interesting things that you'll have to know is the fathers of aeronautical engineering never went to college. I guarantee you the guy that invented the wheel never went to college. The father of electrical engineering, Heaviside, didn't go to college. Michael Faraday never went to college. Benjamin Franklin never went to college. That's a minor point. Okay, but the two main points I want to make, and just wrap your brain around this, of the 1.6 billion people on the planet in 1900, only 2 had the right stuff to figure out the mechanics of flight. Only 1 in a billion people have the right stuff. Then I argue that we humans are either severely retarded or very poorly trained in science, or both. And the other thing you have to take away from this is all the leading experts were wrong. And that is an important point, to understand that scientific progress occurs when the leading experts are proven wrong. Okay, when the leading experts are proven wrong. If the leading experts are right, there's no science to be had. There's no breakthrough to be had. And they're only ever going to be right if science is done. We have been trying to unify gravity with quantum mechanics for the past 100 years. That we haven't been able to do that means we do not have the correct model somewhere. Something is going to get proven wrong. And I think I have the correct models, but hey, I might be proven wrong. That's okay. That's how we learn. We learn by getting it wrong. That's how we learn. We learn to walk by falling on our tiny little butt and saying, oh, I shouldn't trip over my feet that way. So getting things wrong is where we need to understand that that is the path forward. Let's look at case number 2. In 1500s, the population of the world was about 500 million people. And the leading experts of the day, including most of the population, believed that the Earth was the center of the universe. The 1 in a billion guy was Galileo. And he proved the Earth is not the center of the universe. Now, I say the 1 in a billion guy, even though it's 500 million, how many generations lived and died before Galileo came on the scene? Okay, how many centuries did we believe that the Earth was the center of the universe before the guy with the right stuff came along? So I'm rounding this up to 1 in a billion, but it's probably a lot more. Okay, and this 1 in a billion person proved the leading experts wrong and suffered for it. Being canceled is not a new phenomenon. He was basically canceled by the Catholic Church, put in house arrest, and he couldn't publish anything anymore. So you have to understand that the Catholic Church was the leading experts. And they did not want anybody challenging their authority, their supremacy. Because if it got out to the rest of the population that the Earth isn't the center of the universe, then the credibility of the Catholic Church is now in question. If their credibility is in question, their authority is in question. And that's not good for business. And so therefore, Galileo was canceled. Okay, and the problem you have to understand is the leading experts are the ones that stagnate science. And here's a quote from Max Planck. A new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that's familiar with it. Okay, leading experts stand in the way of change because they're worried about their authority, their reputation, and they will oppose any change to that, even if they know that the change is truth and what they've been holding on to is false. Merely, well, you can figure out the human nature behind that. I don't need to beat a dead horse on that. The scientific rules of acquisition are a set of 35 rules to help humans improve the threshold of scientific success from 1 in a billion to hopefully 1 in 100,000. An improvement, I believe, of a factor of 10,000. Okay, the 5th edition of the Rules of Acquisition has 35 rules comprised of 19 tells, 8 fallacies, 3 imperatives, 2 traps, 1 duality, a process, and a test. The test is the final test, how to prove that your final theory is the true theory of everything. This final test, I'm going to release it now, is to run a simulation, a high-fidelity simulation, where you allow evolution to occur, and you allow the evolution of galaxies and evolution of creatures. And the key, the end game of the simulation is when these creatures are able to determine the theory of everything that matches the theory of everything that the rules of acquisition, or that the simulation was based on. Okay, if something completely wrong comes out, completely different from what you look like, completely different from then you can assume that you have the wrong theory of everything. And one characteristic of running this test is you're going to not want to have this society of simulated creatures to be distracted by other simulated societies. So you're going to create your simulation with a single lone species in it. That sound familiar? That maybe we are indeed a simulation, and that when we find the unified field theory, the simulation ends. That's a very interesting concept. So we better get to the end of the simulation before we annihilate ourselves with nukes, which looks like what's going to happen. And so let's begin by showing you how the first rule of acquisition is derived. It begins with Karl Popper, who said, logically, no number of positive outcomes at the level of experimental testing can confirm a scientific theory, but a single counterexample can show a theory to be false. What does this mean? This means it does not matter how many correct answers your theory gets. It doesn't matter how much Brian Greene says that quantum mechanics is the most successful theory ever. It's irrelevant, because a single counterexample can prove that your theory is not a correct theory. That doesn't mean it's not useful. It just means it's not a correct theory. And then Emar Lakatos said we should not think that a theory is ultimately true, only that no counterexample has yet been found. See, in the case of Archimedes' principle stood for 2,000 years as irrefutable until ships' propulsion systems became powerful enough to propel a ship fast enough that the phenomenon of hogging, or squatting rather, occurred. And that showed where the counterexample was for Archimedes' principle. Okay, so it may take thousands of years as humanity's footprint, our capability, our ability to travel, our engineering, our ability to measure how far we travel in the universe. As that expands, that's when we usually find the counterexamples to our existing theories. Because when we make our theories, we make them so they're consistent with everything we know now. But doesn't mean they're going to be consistent with what we know later. Okay, so it's usually when our footprint expands, that's when we find the counterexamples. So if it does not matter how successful a theory is, and it does not matter how many correct answers it obtains, and because we cannot know when or if counterexamples will ever be encountered, then we can never assume that anything we know is the truth. Okay, so what we need is something that allows us to identify false models without waiting for counterexamples. And that's the tells that I have put into the rules of acquisition, and we're going to demonstrate these in a moment. For example, for now, let me show you an example from the Paradox 1 experiment. This is a Paradox 1 experiment. It's a homopolar generator. This video is available presently right now, so you can see this in more detail. And so there are 8 different ways that you can run this experiment. This is classical theory with a static rotating field that rotates with the magnet when the magnet rotates. And these are the answers you get for each condition. These are the two, New Electromagnetism version 3 and classical theory, where you have a static non-rotating field, also gets all the same correct answers. New Electromagnetism version 5, which has an emission-based field phenomenon, also gets all the correct answers. Now, this is where the poorly trained physicists out there are going to say, well, they all get the same answer. That means they're fundamentally derived from the same underlying physics. And I'm going to show you that is, in fact, not the case, because they get different answers for all of the moving parts within. And I'm going to let you look at that and keep on going. So just because they get the same answers does not mean they're based from the same model. That's one of the other fallacies. Okay, so the first rule of acquisition is called the correct answer fallacy. And each rule of acquisition has an aphorism. Correct answers prove nothing except utility. And humans seem to stop at the first theory or model that gives correct answers. I think this is a cross-contamination from mathematics. We'll cover that more in the 12th rule of acquisition video. Just because there are no counterexamples yet does not mean there will never be. Our footprint is expanding, And this again will be covered in more detail in the rules of acquisition series. And to throw the seventh rule out, will be a more detailed version of this in the actual series. It's called the popularity fallacy. Popularity is not proof. Just because the majority of population or leading experts believe something does not prove it's true. Because remember, everyone believed the earth was flat. Everyone believed that the earth was the center of the universe. Everyone believed that burning witches at the stake was a correct thing to do. And there's the stuff that's still going on today that everybody believes is true because everybody believes the same thing. Just because everybody believes the same thing does not mean it's true. It just means it's popular. Now, the tells are an important part of the rules of acquisition. And tells are a common thing in I almost said physics, are a common thing in poker, where little things help one player identify when another player is bluffing or not. That's what a tell is. Like, it could be something as simple as, they're tapping the table, or they scratch their face a certain way, or they always bluff before they do this, or yada, yada, yada. And because it's possible for false models and theories to give correct answers, we need another way to identify false models. The rules of acquisition identify 19 tells. Tells are the most important part. So we're going to cover, with a little simulation, I'm going to show you 4 different tells: the causality tell, the ambiguity tell, the locality tell, and the sentiency tell. Now, these are all derivatives of the ambiguity tell. And so the remedy, if any of these are violated, the remedy comes from the 17th. Okay, and the remedy is that the violation of any of these mean that either your theory model is incomplete, a special case is something more fundamental, or it's completely wrong. Either way, the science is not settled. And that's irrelevant of how many correct answers it gets. So let me give you a little demo here. Talk about this on the bottom in a moment. Okay, F2. So this is a simulation of charges flowing around a copper ring. Now, these blue things here are not the charges. Okay, these are basically halos that tell you the charge is located at the center. The charges are infinitesimally small. They're located at the center of these little spheres. And this is the copper ring. These rings here show how legacy physics shows the magnetic field generated by the moving charges. But guess what? I made a flaw here. This animation is flawed. Because in order to get the correct answers with classical theory, I got to put this over here. Okay. The field lines don't move with the charges. They stay with the copper. Now, this is a fault of ambiguity and causality and locality. Because what tells the field lines? That even though the fields are generated by the moving charges, we know this to be true, how do the field lines know to stay stationary with the copper? And what happens if you just have charges spinning in free space without the copper ring? Well, then how do you determine what they move relative to? What is the frame of reference? There is no such thing as a medium in classical theory. And so we have no understanding of what causes the field lines to stay with the copper, or what to stay with anything. Now, here's the interesting part. If this is part of your homopolar generator and your copper is actually moving, well, then the field lines actually have to move with the copper. How do they know to do that? What is the mechanism? There's no described mechanism. Now, again, doesn't mean it's wrong. It just means we're not done. We have to explain how the field lines stay with the copper. Okay, we can't explain that. And so that's a violation of locality, causality, and both of those are a violation of ambiguity. Okay, now the interesting thing, going back to the rotating field, okay, let's say you're doing a Faraday experiment. Well, Lenz's law says that the charges, if you had a time-changing magnetic field here, which this kind of is, then Lenz's law says that a current will generate that will counter the change in the flux in the center of the loop. Well, first of all, how does a wire know where the center of the loop is? that implies sentiency, because it's out here, nothing happens. Also, how does a change in flux over here impact the wire out here? Well, that's a violation of locality and causality. Okay, so we're violating everything up the yin-yang here. And we'll cover these in more detail when we get to the rules of acquisition. Let me stop my simulation now. And that's why we're going to create a punch chart here for the violations. And I think I missed for Lenz's law. So here I have Biot-Savart and Faraday, Biot-Savart and QV cross B. QV cross B gets the correct answers, but it violates causality, arbitrary, and I believe locality. Oh, I don't have them all checked. Okay, I didn't check all the right ones yet, but we will when we do this for real. Okay, now that you got a brief introduction of the rules of acquisition that will allow us to identify incomplete or wrong theories, even though they give us the correct answers, in order to go forward, we need to give you some definitions to help out. Now, some of you may already know this, but we have natural units. According to the 24th rule of acquisition, there can be nothing arbitrary. Nothing arbitrary. No arbitrary constants of relation. The only allowed item at this point, until we can figure out how to get rid of these things, is arbitrary units of measure. Right now, that's the only allowance for something arbitrary, as long as it's used consistently. And right now, we only have 3 arbitrary units of measure: the coulomb, the meter, and the second. All the other units of ethereal mechanics can be derived from these 3, and presently I believe charge is a function of space. Okay, but I don't have time right now to reconcile that. Right now this works, and then one day when I get some time, I have some things. I've already shown my Patreon members where this works out, how it does, but we're not ready to do that permanently yet. That's just kind of an idea that's being floated around. Okay, now the natural units of force is coulomb per second squared. Resistance is meters per second. Capacitance is 1 over acceleration. Inductance is length. Inertia, which physicists call mass, is coulomb squared per meter, which we've adopted a term Burroughs. We're doing this because the B is no longer needed because the Biot-Savart field is obsolete, so we're recycling the B for something that's related but more important. So the second paper, Constructs, goes into more detail. And the natural units are converted to legacy units by multiplying by Km, which is mu over 4 pi. Okay, this is no longer an arbitrary constant. All it is a conversion constant. It converts natural inertia to legacy inertia, which is mass. That's all it is. There's none of this nonsense about, oh, it's the permeability of free space. That's complete nonsense. We kind of proved that in the last video. Effort is an important and useful concept. It basically replaces what we used to call the electric field, E, because we need both an electric field and a non-conservative electric field. So what we're doing is we're really replacing the E for electric field by adding a subscript, either E, M, or I, to keep track of the source of the effort. Let me give you an example. So if you divide both sides, this would be the legacy electric field definition right here. And this is conservative. So this is electric field at the target due to an electric field. Now it's going to be called the effort at the target due to an electric field. This is the effort at the target due to a magnetic field. And this is the effort at the target due to an inertial field. All you have to do is divide both sides of these equation by QT, and that puts these in terms of effort. Effort is needed to compute volts and Vim. Now, as an alternative representation, we still use E for the electric field, we use M for the magnetic field, and I for the inertial field. And I'm not sure that we're going to continue doing this, but this is done in certain areas instead of carrying around all the damn subscripts. So that's an alternative. Maybe we'll keep it, maybe we won't. Okay, so determining effort is part of the process of determining volts, or Vim. So what's Vim? Vim is what formerly was called EMF. Vim is part of the definition. Whenever you hear the term Vim and vigor, it's like energy. Okay, volts is a unit that describes energy per coulomb in classical theory. In new electromagnetism V5, volt is now refined to express potential energy per coulomb. And naturally, another unit is required to express kinetic energy per coulomb, and the new unit we're using is called Vim, from Vim and vigor. Okay, because one other thing we have to understand is the transfer of energy is always done through force. Now, these are the new electromagnetism V5 models shown at the top. Okay, and we divide both sides by QT to put them in the Vim format. Okay, now if we take the line integral of the electric field DL, we get volts. If we take the line integral of M or I, we get the Vim. And remember, this can also be written this way. And this is conservative, so if you take the closed path integral around the electric field, you get 0, or the effort, the electric effort. If you take the closed path integral around the magnetic force, you get the Vim. If you take the closed path integral around the inertial field, you also get Vim. Now this kind of means voltage from either, this could be Vim or it could be read as voltage from either I or M. Either way, it's the same thing. So in the graduate thesis, this problem was identified, but I had a more primitive definition. In the graduate thesis, you'll see VP for potential voltage and VK for kinetic voltage to replace EMF. Okay, now one thing you should also notice about new electromagnetism version 5 is we get two different notations for Q. That's because these are the primordial equations, and they can be used for either a coulombic or a Pretonic individual preton. So a coulombic system is a system of pretons, and all you need to do in that coulombic system is use the net Pretonic charge of that coulombic system here, or if you're working with individual pretons, it is the charge of the preton. Negative pretons have -1/2 of a unit charge, and positive pretons right now have +1/3 of a unit charge. Okay, but up here, let's talk about this next. The electric force model is emitted by a coulombic system and coupled to another coulombic system. A coulombic system is pretons that spin around at the speed of light. And using the inertial and the magnetic force models, you compute the interaction between all of the source charges and all of the target charges. And when you sum up all of the effects of all of those interactions, you end up with simple Coulomb's model here. This is a far field effect, because when these get very close to each other, there's a lot of other torque effects that diminish at far distances away. Okay, this is for bench tops. This is the force that's present as these things get far enough away, where the radius of the system is much, much smaller than the distance between them. That's what we're calling the far field effect. This Coulomb model is a far field effect. It's the only effect that remains at far distances. Okay, and that's what we're discussing in this NEV5 series, our benchtop effects that can be used for electrical engineering or experimenters. Okay, and that's why, and for this model, you put in the total charge of the source coulombic system, which would be 2½ pretons, which is a unit charge, as a negative unit charge, and then 2½ negative pretons on this one, which would be a negative unit charge. And so these guys will repel from each other. If this were a positive system, you'd have 3 positive 1/3 charges. So it would be a positive whole charge in here. This is not to be used for computing the effect of a coulombic system on a free preton somewhere else. If that's the case, You would have to do all of the calculations that you would do to do this. You would do that to that one. You'd have to go back and use the inertial and magnetic models independently to get that interaction. Okay, again, this is a combined of two Coulombic systems. Okay, so because NEV5 is a series is specific to benchtop applications, engineering, experimenter applications, as such, cases involving lone pretons are not discussed. So all of the models are going to be using Coulombic systems. So you just take the charge of the Coulombic system for all the models. All right, so we have completed the important parts of Chapter 1 of the NEV5 paper, which are mostly definitions. The next video in this series is EM04B, which is how inductors work. Now, this is based on the pre-5.0 paper, so we might have some old nomenclature here, but it won't matter. It'll probably be based on the thesis, which has old nomenclature, but this is still a valid video. And then we have the magnetic force intro and the interfragmentary force video. Again, these might have some old notation for using EMF instead of VIM, but the derivations are valid and they're updated in the 5.0 paper. It's the same model, it just uses different notation, that's all. Okay, this is our Patreon site. If you want to see stuff years sometimes before we make it released to the public, it's $5 a month. Please help out so I can do this full time. Right now, my JOB is the #1 source of funding for this. I would love to be able to hire people to make much better videos than this. This is a repository. I'm going to update this weekend to put in all the links to the presently released videos. There's a lot of links are missing. This is the blog site. Big shout out to Sebastian for taking care of this. And this is the YouTube Premiere site. All of the new electromagnetism V5 stuff and all of that is being done here. People that are on my old YouTube site, I'm going to give you indicators that there's new releases here, but I'm not releasing any more of the new stuff there. That's a historical site that shows how screwed up we were in the beginning until we got past all the brain damage. This is now where all the corrected, fixed stuff is, the new stuff. Thank you. No more voodoo physics.